Students, this video is connected to the November 13th remote class in which we are focusing on raster analytics and advanced sort of applications. We started the series looking at how to create topographical surfaces, and then we spent the last two videos working to create density, intensity, and heat map. And we'll conclude with one video that shows a tool I find fantastic that is called interpolation. And you create and use interpolation to effectively estimate that which you do not know, right? It's using known values to estimate unknown values. And it's only going to work as a tool when you have something natural or human made where proximity determines likeness, right? So temperature, this is how you could create a temperature grid. It's not simply going to be, unless I'm sitting there pumping a blowtorch, that something down the block from me is going to be like thousands of times hotter outside than it is near me, right? Temperature moves in a gradual form. The way people pronounce things, right? These maps that we saw to start the semester, those were made by interpolation, right? Figuring out areas you didn't know by comparing what's around it. And I'm going to teach it to you for one of the things it's very commonly used for, which is mapping out and estimating home sale prices. The interesting thing is that if you control for type, which we'll do in a second, right? Only compare maybe homes of the same sort of size and type, and you control for area, right? So instead of comparing maybe the price of a home, compare it to the price per square foot, then what starts to become important is more so where that home actually is in determining its price. And so if you have a series of inputs like I do here, right? Actual home sales that were recorded, I can use these to get a sense about what it might cost to buy the same home in an area where I don't have a point, right? What would it cost to buy one sort of here, given that I know what's around it, or here, or here, or here, or here. So the first thing I want to do is I want to make sure that we have sort of a usable sample size. So if you scroll over, well, first scroll all the way to the end and see that, I've created a field here called PPLA, price per livable area. So we're going to factor out anything that's zero because we don't want to include that in the analysis. And that's going to be sort of what we're comparing, right? We've standardized and normalized the homes on a total dollars, right? Sale price per livable area. But first I want to factor out maybe only two-story row homes. Let's keep it sort of a simple one. Let's not factor in ones that have apartments or garage. We can compare them to themselves. Let's try to keep it as standard as possible and compare only row two stories. And so to do that, let's leverage an old skill we had. Come on up to select by attribute. Come on in here and say, I want to select where the building description contains the text, and make sure it's all capital here. Row 2 STY. Oh, that was not capital, Shay. Row 2 STY. Run it. Okay, and that'll give me my sample size. And the next thing I like to do is let's sort of come into the selection area here. And let's maybe sort by price per livable area, and let's just sort of remove the outliers. So anything that's zero, I want gone. I can do that from select by attribute too, right? I could come in here and say, hey, selection type, remove from this selection where the PPLA, the livable area, price per livable area, and I could say is equal to 0. Take those out. And it's also good if I search by the livable area to usually account for sort of crazy outliers here. You won't always find them, but sometimes it's good to remove them. A lot of these are really high sort of price per square area, but I do notice something sort of interesting that these ones are all kind of connected. They're in the same area. They all had the exact same sale price and same date. So it seems sort of like a multi sort of property sale at one point, and they have massively inflated sort of sizes. So I'm just going to remove those, right? So I just sorted by price per livable area, started with the 3411G down to the 3057, and I'll highlighted them in yellow, and then I'll come over here. And to do that, I clicked on one and then the other while holding shift. And I'll come over here to the highlighted, and where it says unselect, I'll unselect the highlighted. All right, so I've got my 8,700 or so homes that I'm going to use this for. And IDW is located under Spatial Analyst Interpolation IDW. It stands for Inverse Distance Weighted. And really what it means is your proximity to me influences your weight upon me. So if I'm trying to figure out what it costs to buy a two-story home here, I will calculate my estimated price. I will interpolate it by saying that this one matters, this one matters, this one matters but a little less, this one matters less, this one matters less, this one really doesn't matter. I could give a shit what's going on here, right? The closer the points are, the more influence and weight they have mathematically on what your value should be. And so if I were to come in here and drag in the home sales, again, Z field is what you're going to interpolate, and this is going to be the price per livable area. I'll call you maybe, ID. Well, let me get to my output file, my raster output. Where'd you go? PPLA, price per livable area. Get my cell sizes back down to 25. Power, I'm cool if you leave it at 2, just to let you know what this means. IDW stands for Inverse Distance Weighted, so effectively the weight, right? A point's weight, its influence on what my value would be, my predicted value, is going to be the inverse of its distance, right? So if you're 10 feet from me, the weight will be 1 over 10. If you're 100, it'll be 1 over 100. All power does is add an exponent to that. So then if you're 10 feet away, it would be, right, 1 over 10 squared. So it would exponentially impact sort of distance, that the farther away you move, your influence wanes dramatically. It's pretty customary to just leave that at 2. I don't see you needing to be messed with that. This is important here, search radius. You have 2 options, either fixed or variable, and notice that as you do it, it'll change the orientation here. Let me walk you through it. Variable means to calculate my value, and each pixel is going to do this. Each pixel will look around and find the closest 12 points, right? Those 12 will be what it uses to influence its value. The closer they are, the more influence they'll have. But it won't search after a certain distance. And I might use this here, right? Because I'm creating a map that does have large gaps, right? There's a lot of area here without sort of 2-story row homes. And if I don't put in a maximum distance, it's going to try to interpolate what that is. It's literally going to stretch as far as it can to find the 12 closest points, and it might stretch so far that it's stretching away from meaningful values. You could also do this the other way. You could say, hey, just literally look around you in 500 feet, 1,000 feet, and use all the points around you, but you have to keep looking until you find this many points. Up to you. Try out a couple. Let's just start nice and simple. Keep it 12 points from the start, and let's say this, right? Once you've looked past 1,000 feet, if you're not finding a point, and we could even shorten that down, maybe say because there's so many so clustered, like 500 feet. If you don't find any points within 500 feet of you, don't tell me your value, because that just means there's probably not a lot of that home type around me, so it's difficult to make an inference. We won't have to go through this, but this is a cool thing. If you do have instances, and it's not the case here, but let's say we assumed that Broad Street was a crazy barrier where the right side of the street and the left side of the street are so different that they shouldn't influence each other. You could load that as a polygon barrier and they won't search across it. So let's run it. It'll do its thing. And again, I'm going to get a scale. It's going to come back and it's going to show me ranges of price per livable area depending on where I am in the city. And now I have something pretty cool, right? And again, I limited it to 500. Maybe in the future I'd make that, actually I'm going to make it 1,000. I think 500 was a little too radiusy, and I sort of want to fill in the gaps a little more. So I'll say, hey, don't go beyond 1,000 feet. So mulligan on that one, run it. But then we can sort of look at the output, analyze it, and sort of understand the mass utility of something like this that lets us take known home sale prices and predict what something else might be. So here it comes. Perfect, right? So now I've got interesting values here, and it's broken it down to me. I can choose my own values. I can sort of, change my symbology, but we'll stay with this for now because it's somewhat instructive to what I want to give. So we'll come on up here to appearance. We'll make it a little transparent, and we'll start zooming in and seeing what this is telling us. So we're starting to see, right, that the home sales are going from sort of the green being $31 up to sort of $2,700. And it's starting to make a lot of sense, right, once you sort of take out those outliers, that Right here, right, Broad Street becomes that interesting dividing line. These neighborhood here, those of you who don't know the city, this is sort of Point Breeze, which is a historically black middle-class community that has seen a lot of gentrification pressure in the last 10, 15 years. It is like literally ground zero for gentrification in Philly. And you can see that on the edges, right? The edges is where that's sort of pushing in. You know, it's even gotten so crazy. This is a totally invented neighborhood here by real estate professionals called Newbold, you know, as a way to sort of maybe make it seem like it's not Point Breeze, but it is. It's caused no amount of tension with sort of the neighbors in there. And what you get in an area like Point Breeze that's so fascinating is almost like a block over block sort of change, right? Areas where they're still cheaper, but pockets where newer homes have been sort of built, inflating up their area. But again, as you start to come over here, the homes, increase in sort of value. Push yourself towards Center City and, you know, Queens Village and such, and they really do pick up. They pick up, they pick up, and they pick up. Come on up here and we'll go into West Philly. Not too many sort of two-story homes here. You know, I'd probably do, if I were to redo this analysis, I'd look instead at the price per square foot for like the three-story Victorians. But at least in sort of Mantua and stuff, we can kind of see, like if I'm in Powelton Village, which is sort of the area closest to Drexel, the home prices are a little bit higher than as I'm sort of heading up here into Mantua. Come across and I'm in Fairmount, extremely sort of high-priced, expensive neighborhood here, and as it starts to push into Brewery Town and others, the price sort of depletes. So it's just a different way of visualizing what you'd see. If you only have a certain number of values that you are known, you can use those known values to try to predict the unknown area. And that's what's coolest, right, is if then I had a layer of home sales, I could layer them on top, and I could almost use that to predict, right? If I wanted to buy this home, I could predict probably, you know, click on the raster right next to it, that a reasonable price there would be like 125 feet per square mile would be a good reasonable price for that house given everything that is around it. So that is Interpolation. Awesome tool, definitively and frequently used in sort of home sale analytics, but can be applied to sort of any of those spatial processes where the fact that would be true is things closer to me are more like me than things far away. As long as that principle is true, you can run a tool like this to predict the values you do not know.